Lecture 4, Relativity. In the new study design, the relativity section has been worth on average 5% of the paper. I've divided it up into a few sections. The first one is Einstein's two postulates and the consistency of the speed of light. The second section are the ideas of time dilation and length contraction and the use of the Lorentz factor. The next two sections involve muons that are particles that travel at very high speed, and so we need to take relativistic effects into consideration when we're analysing their motion. And the next idea are Einstein's equation for the total energy and the link between the total energy, the rest mass energy, and the kinetic energy. I have divided the questions from the papers from 2005 onwards into subsections to help you find the things that you know and the things that you don't know yet. For the first section, I have divided it into 4 subcategories. The first one is frames of reference, then we've got Einstein's two postulates, then we've got the differences between an Einsteinian prediction and classical physics predictions, and then questions based around the speed of light being constant. A reference frame is just a set of coordinates to allow us to find the position or change in position of an object in relation to a particular point. In this study design, you only need to deal with inertial frames of reference, which are frames of references that aren't accelerating. To date, the exams have just tested you on finding the frame that is accelerating. You need to remember that when a frame is moving in a circular motion, its velocity is not constant, its speed may be constant, but it is an accelerated frame. Einstein's two postulates are that the laws of physics are the same in all inertial frames, and in a vacuum, the speed of light is always the same, 3 by 10 to the 8 meters per second. Time dilation questions and length contraction questions can be categorized into 4 different types. The first one is going to ask you to find the proper time or to use time dilation. The next one is to find the proper length or to use length contraction. Then the next type of question will be involving calculations using the Lorentz factor. And the last one is just a really simple version of relative velocity where we're using the distance travelled is c times t or v times t. Proper time is the time measured in the frame of reference where the clock is stationary. Proper length, L0, is the length in the frame where the object or the distance is stationary. You need to be aware that proper length and proper time are measured in different frames. Proper time is measured in the moving frame and proper length is in the stationary frame. The Lorentz factor, gamma, which is equal to 1 on the square root of 1 minus v squared on c squared, is always greater than or equal to 1. The lower the speed, the closer gamma is equal to 1. I think you should put on your cheat sheet a set of values for calculations involving gamma, so that when you need to do one on the exam, you actually have some reference data to compare with, just to check that you've got the calculation right when you're doing the exam. The proper length is the length measured in the rest frame, in which the object is at rest. If you are measuring it in a moving frame, then the length will have contracted. The length in the rest frame is always the longest, and it will be shorter by a factor of gamma in any moving frame. Time in a moving frame will be observed to run slower than time in the rest frame. This is time dilation. I think there is a basic process for solving all of these time dilation and length contraction questions. 4 steps. The first one, find the rest frame. Identify which is the rest frame from the question being asked. Understand that the length is always longest in the rest frame, the time is always shortest in the rest frame. So if the question is asking you to deal with something in the moving frame, then either multiply or divide by gamma to change the size of the value. Muons and other particles travel at high speeds. Because they're travelling at such high speeds, you need to take relativistic effects into consideration when dealing with them. When you're answering questions on the exam about these, make sure you are answering the question that's being asked on the exam, not what you have on your cheat sheet. There was an example a couple of years ago where the students all answered about muons, but the question specifically said particles that weren't muons. The energy ideas can be grouped into 4 subcategories. E is equal to mc squared. The kinetic energy is equal to half mv squared. The change in the kinetic energy is equal to the work done. And the total energy is equal to the kinetic energy plus the rest mass. Einstein not only linked space and time together, he linked mass and energy. This gives us an equation for the mass energy, which is mc squared is equal to the kinetic energy plus the rest mass energy. The rest mass energy is given by E is equal to m naught c squared. If we substitute in the fact that m is equal to m naught times gamma, then we're going to get a rearrangement of the equation to give us that the kinetic energy is equal to gamma minus 1 m naught c squared. This is a very useful equation, and this will be significant when the speed is greater than 10% the speed of light. Nuclear fusion is the process of 2 atoms joining together to create a larger one. In our Sun, 2 protons combine to form helium. The definition of an inertial frame is a frame that's not accelerating. The only frame in these options that's not accelerating is B. Light is an electromagnetic radiation which travels at the speed of c through a vacuum. If it's not travelling through a vacuum, if it's travelling through a medium, it slows down. The rate at which it slows down depends on the electrical and magnetic properties of the material that it is travelling through. Therefore, the best answer is B. This question has been asked in a variety of forms on quite a few papers. We are trying to get the idea that if you're travelling at a constant speed, but in circular motion, you're accelerating. An inertial frame is a frame that's not accelerating. The only one of these frames that's not accelerating is D. This question was poorly done. Only 25% of students got it right. We should have been able to eliminate B and C because we know from general relativity that neither of those are correct. The problem was what was happening with A, and we should also understand that when light travels through a different medium, it slows down. Its speed of light, c, is only true when it is travelling in a vacuum. The reason it slows down when it goes into different mediums is because of the electrical properties and the magnetic properties which are associated with it in the other medium. Therefore, the answer was A. Back in 2010, this question was done very poorly. Only 16% of the students could get it right. It was a bit difficult because there was some language hidden in the middle of the question. We are told that carriage A is moving at a constant velocity of 0.9 c, therefore it's not accelerating. We are told carriage B is moving at 10 meters per second and decelerating. Therefore, it is a non-inertial frame. This makes the answer A. We need to use non-relativistic methods to add the speeds together. Trull's travelling at 40 metres per second in the same direction as the sound is travelling, so he will think the sound is travelling at 300 metres per second relative to him. Mary is moving against the direction of the speed of sound, so she will actually think it's travelling at 380 metres per second. Therefore, the answer is B. Back in 2008, this was the typical follow-up question to question 7. And here we are just trying to get you to understand that in a vacuum the speed of light is c. Therefore, the answer will be B. I don't think we'll get a question like this anymore in terms of 2 questions, one after another, but both ideas independently are still relevant. This question was not done very well, with only 25% of students being able to get it right. I suspect a lot of the problem was the language and the wording of the question. It's a little vague. The navigator on the spaceship Hector would have understood that the radio signal would have travelled at the speed of light, c. Using their classical understanding, they would have felt that because they were moving at 0.4 c, then the signal was coming towards them at a speed of 0.6 c. Therefore, the answer was B. You start from the point that the proper time is the shortest time. And in any moving frame, the time is going to be longer. Therefore, the answer is C. Jim is in the rest frame, so he is going to measure the proper time and the proper length. Use that the time is equal to the distance over the velocity to get 3.3 microseconds. Therefore, the answer is C. Jim is in the proper frame. Susanna is in the moving frame. Susanna is going to measure the contracted length. If you do the calculation, you get gamma is equal to 2.29. Dividing 1 by that gives me 0.44 meters. Therefore, the answer is A. The proper time is always the shortest time. It's the time measured in the rest frame. In any moving frame, the time is going to be longer than that. Therefore, the answer is A. This question was not done well. Only 37% of the state could get it right. The satellite is moving horizontally, so in the vertical direction there is no change in length. Therefore, the answer needs to be C. The rest frame is the frame of the particle. The scientists, therefore, are in the moving frame. In the moving frame, we can get the time that the particle exists for by going d over v, and that's going to give me 2.16 by 10 to the minus 11 seconds. Gamma being 1.81 means that the proper lifetime must be this value divided by 1.81, which gives me 1.19 by 10 to the minus 11 seconds. Therefore, the answer is C. Length contraction will only occur in the direction in which the object is moving. Therefore, because it's moving in the vertical direction, we will only get a contraction in the vertical direction, giving an answer B. Length contraction will only occur in the direction of the velocity. Therefore, because it is moving horizontally, we will get a contraction in the horizontal, giving the answer B. Time dilation and length contraction change by the factor of gamma. If we don't want them to change, then gamma needs to be close to the value of 1. Therefore, the answer is C. Given that gamma is equal to 4, this is a straightforward substitution into a formula to find what the speed v is. On substitution, you should find that v is equal to 0.97 C, giving an answer C. This is one where you should also be checking on your cheat sheet to make sure that this answer is consistent with what you've got stored on your data sheet. In the laboratory frame, the distance travelled is 600 metres. In the electrons frame of reference, that will be the moving frame, the distance will be shorter. Gamma is 4, so 600 divided by 4 is 150 metres, giving the answer D. In the muons frame, its half-life is 2.2 seconds, and it will travel 660 metres. In the Earth's frame, which is the moving frame, the time will be dilated, so it needs to be greater than 2.2 microseconds. Then, because it is greater than 2.2 microseconds, travelling at 0.999 c, it is going to travel a greater distance than 660 metres. Therefore, the answer is A. This is a simple example of time dilation. In the muons frame, its half-life is 2.2. In the moving frame, which is the laboratory frame, its half-life is 5.0 microseconds. Use these bits of information to find that gamma, and gamma is equal to 2.27. Once you know that, you can find the ratio of V over C, and then find out that the velocity was 0.9 or 0.90 times the speed of C. Use E is equal to mc squared, but m is the mass of the pion and the antipion. So this is going to give me that the combined mass is 5 by 10 to the minus 28, which means that the mass of the pion must be 2.5 by 10 to the minus 28 kilogram. Therefore, B. We know from the previous question that the rest mass of the pion is 2.5 by 10 to the minus 28. The work done is a change in the kinetic energy, which is going to be given by gamma minus 1 m naught c squared. If we substitute in, we're going to get that the work done is 4.5 by 10 to the minus 11 joule. Therefore, the answer is A. This question wasn't done particularly well, with only 39% of the students being successful. We start off to find the kinetic energy of one or of each proton. Use gamma minus 1 is equal to m naught c squared, gives me that gamma is equal to 7,308.32. We then use the link that the mass is equal to m naught times gamma, and that's going to give me the mass of 1.222 by 10 to the minus 23 kilogram. We actually need twice that, because we were just working out for each proton, so we need twice that, which gives me 2.4 by 10 to the minus 23 kilogram. Therefore, the answer is B. The work done is a change in the kinetic energy. The kinetic energy is given by gamma minus 1 m naught c squared. So the change in the kinetic energy is going to be the difference between the two of them. So it's going to be delta gamma m naught c squared. Once we substitute the values in, we're going to get that the work done is 7.5 by 10 to the minus 12 joule. Therefore, the answer is C. This question was not done particularly well, with only 41% getting it right on the day. I can understand that. Some of the answers are a little bit unusual. Option A isn't correct. Option B, which is talking that the rest mass is going to change, is incorrect. Option D is not true mathematically, because gamma is going to be greater than 1, so it's going to tend to 0, not tend to 1. Therefore, the best answer is C, which is correct. Use the kinetic energy is equal to gamma minus 1 m naught c squared to find out what gamma is. Once you know that gamma is 2.29, substitute in and find out what the speed is, and that gives me V is equal to 0.9, so the answer is A. The initial mass is greater than the final mass. This change in mass has been released as energy. Used E is equal to mc squared to find that the energy being released is 3.6 by 10 to the minus 13 joule. Therefore, the answer is B.